So this is a real quick talk on what we've done at IBM on a couple of different topics around scaling the plane. I'm going to turn it over to Liran to start with to talk about conditional monitoring, and then we're going to cover a couple of other things we did on the wire protocol and an attempt that we did to try and do incremental processing, and then talk about what we see as needing to still happen. So.
Okay. So I will on monitoring. So let's take a look on the OVN architecture to see what we wanted to tackle. So at the bottom up, we have the cloud management system. OpenStack case, it is a Neutron, which defines the logical network topology and writes it down to the northbound. Okay, so the Neutron writes the logical network topology to the northbound DB. It defines the logical network, the logical ports, and from there, the north D translates it to the southbound DB into the logical flows tables and all other tables that are in southbound DB, which is a lower abstraction layer. And from that point, it is being pushed down to all the compute nodes, to the OVN controllers, by a monitor request, which is a request of the OVS DB protocol. And therefore, all the changes that happens in the southbound DB are being pushed down to the OVN controllers. So what we recognize is that we have many redundant flows on each compute node, and we have high processing overhead. So we wanted to tackle that, and the solution was conditional monitoring. What happens in conditional monitoring is when a new VM is plugged on a specific compute node, the OVN controller on this specific compute node will send a new condition to the southbound database through the OVS DB protocol, and all other compute nodes will do the same, and OVN will behave normally, define network topology in the northbound database, and then writes it down to the southbound database, but updates will be pushed only to the relevant compute nodes. And by that, we will save many redundant flows on the compute nodes. So it is actually an OVS DB protocol extension, and we exposed two new requests in the OVS DB protocol. The first one is monitor cond, which allows the clients to start a conditional monitor session. And then the second one is monitor cond change, which allows the clients to iteratively change the conditions of the existing monitor session. So inside the code, we exposed a new API in the OVS DB IDL layer, which allows you a typical usage. Like you can see at the beginning, we are calling the OVS DB IDL add clause false for a specific table, in this case, table A, which means that we do not want to be updated on nothing on this table. And then we have some kind of a working loop, and during this working loop, the user will call for another API, which is OVS DB IDL add clause to table A with a specific clause. The condition and clause is defined in the OVS DB protocol. And from that moment on, this client will be updated on changes in the table which match clause 1. You can add and remove clauses iteratively in this API. We implemented a patch to OVN to use this API it is something like 250 lines of code. And then we did a performance evaluation of this feature. We used OVN sandbox to simulate a data center with 50 hosts. And on top of that, we did the performance evaluation. And as you can see in this graph, we measure the total computation in the whole data center. The blue is the OVN controller cycles. The green is the northbound, and the red is the southbound computation. And as you can see, we reduce computation heavily on all data center. At the right side of the screen, you can see that the number of logical flows, the actual flows on each host was reduced dramatically, as you can see. Here, the graph shows the CPU utilization, both on the host, which runs the OVN controller. You can see the red line is the master of OVN, and the blue line is the conditional monitor patch. And also on the southbound OVS DB server, you can see that we do not have any overhead of computation in this case. So from the beginning, we had the question that it was obvious that we are going to reduce heavily the computation on the client side, on the side of the OVN controller. But the question was if we are not going to move the computation to the server and make a new or already existing bottleneck. So we did the following experiment. We measured the influence of the network spread over the data center, which means if you look on the left column, we have here each logical network is spread over only 6 of the hosts from the total 50 hosts. On the right column, you have that each logical network is spread over all 50 hosts of the data center. And in this case, it is obvious that all updates will be pushed to all the clients, because all clients has logical ports on all logical networks. So we were looking at where is the tipping point, where we are have more computation on the server side, and you can see that only on the third from the right column, where we have 42 hosts from the 50, only there we have a tipping point that our patch of conditional monitor has a higher computation on the server. So this is a pretty good result. And this patch is included in 2.6 on the server side and is waiting to be applied on the client side of OVN for now. Okay.
All right, so that's actually an important thing when you work with OpenStack, because if you're trying to do provider networking, you're off on the right-hand side of that page. So that's something to keep in mind if you're using OVN with OpenStack. Since that's what we were doing, one of the things that we also looked at was how could we improve the protocol options for changing data. One of the problems we ran into when we tried to run scaling tests was that very quickly we overloaded the path from the networking OVN control system to the northbound database. And that happens to be because unchanged, we're making OVS DB makes use of the read, modify, write to make sure that the data is clean, and that ends up causing you to transfer the entire state of the client, especially when you're trying to add lots of ports to a network. You also have mutate out there, which only transmits deletes, and thank you to the wonderful folks at HPE who put together the original partial map update condition. We just took it and made it work with sets. And then up in the CMS, networking OVN, there was a couple of patches that actually called this new function. And the question is, well, what does this do for us? This is a comparison of packet size from TCP dump, first packet only. So we basically ran a rally test, throwing a bunch of ports onto a switch, along with ACL entries, and we very quickly maxed out the first packet size to 65K with running the read modify write. That's, like I said, that's just the first packet. We actually got the message size up to somewhere around 2 meg before we realized that we could stop it and we were done. When we switch over to using mutate, we have the blue line there, which is pretty much dead constant. Now, there is a trade-off here because you're doing mutate, you're not checking the current state, so you're taking a chance that your current state is always correct. But it lets you scale much, much better. Another test that our networking OVN guys ran was to actually run just a simple 10 instances from Horizon. This isn't fancy rally, this is just timing what Horizon did, and they saw like a 40% improvement without having to do a whole lot of work. So this we thought was a big win. This is in 2.6, so you can feel free to make use of it. We've done the good side. Now let's talk about the didn't quite make it side. We spent a lot, or I should say I spent a lot of time chasing incremental processing. Today, in 2.6, the OVN controller process does a full recalculation of OVS flows every pass. This doesn't scale. I mean, we were pegging CPUs right and left as soon as we tried to punch it up. Including, we also saw the controller loop was starting to lag, and so we got into a staircase function where we would see flows being set by the networking OVN, and if you looked at how the flows showed up, you would just see it start to stair step up, and it would just sit, and eventually it would catch up and get another couple thousand flows, and I mean, that's an ugly thing at scale. So can we only do recalculate just based on changes? Well, we tried, and it didn't quite work. Turns out persisting state is really, really hard in OVS because there's a lot of things going on. And if you don't get them right, weird bugs happen. Also because of the way that OVS was structured, and I'm going to give Ben a plug here in just a second, there were a lot of backdoors to recalculate everything to make sure you got it right. And so at the end of the day, what you had was, yeah, it would basically not do anything when you weren't configuring it, but when you were trying to actually scale up or scale down the network, you were essentially doing what we do today. So, I mean, yeah, quiescing the OVN controller when you're not doing anything is great, but there are easier ways to get there. Now, Ben has done a lot of rethinking on this and has some proof of concept code, which hopefully will make it in 2.7, hint, 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 that takes a much better intelligent view of this and actually recalculates, takes a look at the inputs and what on the output side in terms of flows changes and goes at it in what would be a much more intelligent fashion. So, I mean, so hopefully we'll see some good stuff with this because I still think there's a big gain that we can get here. Last but not least, I know that folks were talking about the database, and let's just talk about the database real quick. Today, the best you can do with OVSDB is you could split the northbound server, the northbound database server from the southbound database server. That helps somewhat, but there's no horizontal scaling. So on the northbound side, if I've got Neutron talking to OVN, I get what I get. I mean, part of the problem is if I go back and look at out-of-the-box OpenStack, because I'm using RabbitMQ, I can horizontally scale out the number of hosts and get some improvement in my concurrency. I can't do that here. On the southbound side, once you get to about 2,000 or so hypervisors, the southbound side starts to keel over because, again, you've only got one server. If you could get yourself a cluster, you could shard, and you could start to really horizontally scale this stuff out. Now, I know the folks at VMware are looking at etcd and various technologies for scaling this. That's going to be, at least in our mind, the next big step to kill. And with that, thanks for listening, questions, and we've got some time to catch up for the next talk.
Let's thank our speakers.